Mike Butler here from Butler-Justice today. We're going to discuss his company and his background, history, and all the great things he's done for this industry. So, Mike, you're president, owner. What is your position over there at Butler-Justice?
President, CEO, designer, engineer, field worker, everything. Whatever it takes, Brian.
All right. Now, when did you start your company? What year was your company started?
We incorporated Butler-Justice in 1998.
Okay. Prior to starting Butler-Justice, what were you into? What got you into wanting to start this company? Then we'll talk about what your company does and all those things. But what got you interested in getting into this business?
I started out, it's a long resume, as we all have, but started out working for a high chrome foundry in Southgate, California. And we made equipment or wear parts for the aggregate industry, for vertical shaft impactors, horizontal shaft impactors, chute liners, Nyhard, and high chrome castings. And that's where I met Mike Justice. He was the vice president of Pacific Alloy Castings in Southgate. And we both had the same work desires, worked late, kind of the same temperament as far as we were both Boy Scouts. We both had that trustworthy, loyal, helpful, friendly, courteous, kind, obedient, cheerful, thrifty, brave, clean, and reverent, be prepared.
Right.
Michael had a real talent to look at a complicated problem and make it simple. That's his upbringing in North Carolina. A simple country boy that just kind of cocked his head like a dog and say, why do we have to do it that way? Why can't we? He used to say something like, it takes an engineer to design a system, but it takes a really good engineer to design a simple system that works. But we take a lot of pride in providing simple solutions and that work. I had a company called Production Parts and Equipment. We were at an AED meeting, actually, or I was, and one of the companies I represented, which was Telsmith and Pioneer, I was too small for them. I had a lot of success selling their equipment, portable recycling plants, specifically crushing concrete and asphalt. But when that meeting happened, they told me that they wanted somebody with more infrastructure, more brick and mortar. And I called Mike frustratingly that evening on the way home from San Diego, that meeting. And he goes, why don't we just put something together? Why don't you and I just do this together? And we'll create all that infrastructure, which Mike had a lot of office procedures, and he understood all that business of the business things that I really didn't. I was a sales guy, I was an engineer. So he brought that to the table, and he would say, you just go out and do what you do well. I'll stay here and do what I do well. And that was in 1998. Dust collection's a big deal in our industry, and it's been a really big deal in Southern California. Up until now, it's a big deal everywhere in the country and in the world. We took a Donaldson, another company we represented, Donaldson dust collector, and applied it to portable plants where they could adhere to the strict regulations from South Coast Air Quality Management District and still travel portably with the dust collector, adhere to the regulations, do everything they needed to do to satisfy their permit, but still travel with it. Until then, people had to have standalone dust collectors, which doesn't travel well. Very difficult to do. But Mike saw a dust collector that they made that's called an insertable that sits on top of silo. A bin vent is more the industry term. But he said, why can't we put this on a portable plant? I said, I don't know. And he started, I still have the drawings right here in my file, the original sketches he made, back in actually, in 98. And solve that problem. So he saw a need always, and then we went about massaging it and making it palatable to a customer. And we have to date, I think, 2,070 of these that we've sold to different applications.
So was that your first real innovation?
We took something that they used as a stationary thing, set on top of silos, say a cement silo, where they're blowing cement into a silo. And, with the powder that's being blown into, there's a lot of cubic feet per minute of air that blows it in there. Well, that clean air has to vent through something that would be a dust collector that's set on top of the silo. We used that technology to put on a jaw crusher, a cone crusher, a vertical shaft impactor, a horizontal shaft impactor that even traveled down the road.
Okay.
And solved that problem, where the solution before was, well, we make dust collectors and it's this big, gigantic thing that sit in the middle of the plant with ducting and, a big spider web of ducting going to pick up points. And by the way, these are in All-American. I mean, Vulcan has, I'm just guessing 60 of them in their stationary aggregate plants.
Did that help launch your guys' company a little bit, or were you already doing great with all the other products?
We were doing well with everything else. We're a small company, still a small company. We like being small. Boutique allows us to pay attention to our customers better than a big company. Everybody in the company has ownership in, the solutions and the service that we provide. Actually, we started that in Nevada for a company, Nevada Ready Mix, that had a problem, and they had to put dust collectors on every transfer point coming out of the pit. Well, if you can imagine the amount of ducting it would take to a central dust collector over miles, impossible. So we use these small insertables, and we could put one at every little transfer point and satisfy what the air district wanted and the adjacent school, for the children's air quality. So, people complain about the air district, Brian, a lot, like they're charging us all this money and we have to put blah, blah, blah. But, if you were raised in Southern California, back in the 60s and 70s.
And had smog alerts and everything.
It had smog alerts and you couldn't breathe and you weren't allowed to go to school. We don't have those anymore. I mean, our sky's blue. It's we very rarely have an inversion that causes us. I don't remember the last time my chest burned.
Right.
Over smog, right?
So you moved from there. What was your next product that you guys came up with? Was Blue Smoke next?
Yeah, I think the Blue Smoke probably was another situation where there's a requirement for the air districts to solve this. And in the past, there were electrostatic precipitators. These are used at Burger Kings, wherever they're where there's oily smoke. These are where some of these, I'll call them archaic now, solutions to oily smoke. Electrostatic precipitators have a pre-filter and then electronic wires that attract the oils, and they drip down into a pan and you collect those. But electricity and volatile oil droplets don't mix because it creates a fire and they burn. And there were many, many, many fires. So we had a customer in San Diego. You probably remember Don Daly.
Oh yeah.
Yeah.
Sure.
Great Don.
Yeah.
And he had become friends with us, and he asked us to solve this solution or come up with a solution for his problem. He didn't want an ESP, electrostatic precipitator. So we sat up and we talked, and there was a company, air cleaning technology, that had a filter system that we thought could work for our industry, and we applied it, and it was a series of filters, first 4 stages. So Don said, okay, whatever it takes, just do it. So we put this down at the Carroll Canyon plant in San Diego. And the company we bought it from was here in Santa Ana. And we sat up, I think it was 3 in the morning when we finally left the office. We represented Donaldson. Donaldson made a filter for the automotive industry, for machining. It's like coolant for machining.
Same company that you worked for the dust collector. Right?
Exactly. And Mike says they make this other thing. The name was I forgot the name of it now. Special collector for that, but they're very small, modular for a machine, a mill or a lathe. It collected that smoke, which was created by friction, and the coolant had oil in it, and we captured those fumes and went through a collector. He said, "Do you want me to go back and look at this?" So he went back to Detroit, went to GM, went to Ford, watched these things work, and came back and he goes, "I got an idea. What do you want to do? We can either deal with ACT, who's not customer oriented, or we can redesign this thing to fit our industry." And so we sat there and we talked about what makes it simple, using those filters, using 7 stages, our current collectors, 7 stages that, point our final filters at equal to a HEPA filter. It's a DOP filter that is 0.3 microns, so very, very efficient, but you can't inundate a final filter with all this smoke because it'll clog it up, right? So we had coalescing filters prior to the most expensive filters at the top. And it completely redesigned what they had, but used their idea and then massaged it, into a solution for the asphalt industry. Each filter can process 2,000 CFM, 2,000 cubic feet of air. So when we design a system for an asphalt plant, we calculate the cubic feet of volume that we need to do an efficient job of, the capturing efficiency. There's filter efficiency and then there's capture efficiency. When we grab all that material, we go, most common is 48,000 CFM. And each one of our filters processes 2,000 CFM. So the math is pretty easy on sizing a collector. Don't want to be undersized because there's the efficiency drops if there's an air to cloth ratio that you have to take into consideration. How much air can one filter process through it? If you have too much air,
take one filter. Are you talking about them 7 collectively, or each individual 7?
Each filter is a stage that does a job.
Okay.
Our first stage is a coalescing filter. It's really an impactor filter where it's a chevron style filter where the air has to be forced through a V. The air comes up, hits this V, and then has to pass around it. So we're making droplets. We're taking droplets out all the time. And just to back up, blue smoke isn't like a dry smoke. It's an oil. It's tiny, tiny droplets of oil that need to be coalesced into a larger droplet so it can be filtered out. So, the beginnings of this is to understand that kind of like a cloud. You see a cloud in the sky, it's full of water, right? It's just a mist and it's sitting there. And it just carries that water until an inversion creates the pressure where those droplets coalesce into a bigger droplet and then get heavy enough to drop out. Okay. So what God gave us, as far as clouds and rain and all that, we kind of create that in our collector. We're impinging those tiny droplets into larger droplets that are then filterable.
This product, Blue Smoke Control, did it come into, first of all, I want to ask you where it's placed at the plant. And second of all, I want to ask, did you get into business because it was mandated? It was a good idea, people are being good stewards of the environment, or was it mandated? How did it come to be? And then where is it placed in the plant?
So the mandates by the air districts, whether in this first case was the San Diego Air Quality District for Don Daly, he had to have something because there was encroachment of housing and businesses to his plant that was in a canyon away from everybody at one point. Then everybody started moving in and they can smell, the distinct odor of asphalt. And so the district says, every time someone calls, we have to go out and find that source. You're the source. You need to do something about it. Nobody wants to buy a blue smoke collector, but sometimes you have to. and that's to appease a permit requirement. That's to appease the public, your workers. At the end of the day, it makes the asphalt plant environment cleaner, better. It is the right thing to do, but if you don't have to do it, you won't have to. You won't do it. Sometimes customers are forced into doing something, and it's going to become a fabric of every plant permit eventually, and it's happening all over the country.
What's the statute now? What's the
It's different everywhere.
How about California?
California, any new plant has to have blue smoke controls in it.
Okay.
Any new plant.
The old ones are grandfathered?
Some are, but that's going away. It's the air district's job to make those grandfathered situations go away. So if you have a plant and, we now have requirements for burners in asphalt plants, for CO, NOx, etc. If you can't adhere to that, now you have to put a new burner in. Well, when you put a new burner in, you apply for a new permit. Now that permit is going to be governed by the new source review that says you have to also put in a blue smoke collector.
Okay.
If you put in a new silo, you have to adhere to the new source reviews. So you have to put in a blue smoke collector.
Are you the number one distributor in the United States?
Oh yeah.
Oh, okay.
We're in the, I'm going to tell you that I'm pretty proud that, we have well over 100 of these in plants in the US, Mexico, Australia, and in Europe now.
Oh, wow.
So Europe, the clean new Europe deal is a big deal, and so Finland has embraced the technology. We're working with some of the German people now because they want to be clean by, they said 2025. I think that Merkel has changed. I would say easily we're the biggest supplier of plant controls in the world. That's a big statement because we have 6 other countries that Canada also, I forget about Canada.
This blue smoke, I think I have an idea of where it might be on the plant. You explained it to me the other night, but can you explain it again? Where does it attach, and how does it? Is it like a vacuum? How does it keep all this droplets and?
So when you make asphalt in simple terms, you have a big dryer that gets asphalt or aggregate, sand, rock dust up to a very high temperature, and at the end of that dryer, drying all the moisture out of the aggregate, then they add oil. Well, when oil hits 600-700 degree aggregate and sand, dust, it burns, it smokes. So that's at the end of the dryer. And then there's usually an incline drag that goes up to the top of the silos where if there's 2, 3, 4, 6, or 8 silos, that asphalt now, it's black and hot, is distributed to each one of those silos depending on product size, depending on blend, depending on what product they're making, those individual silos. Well, at the top of the incline drag or bucket elevator, heat rises. God gave us that. Thank God, because all that smoke rises. So at the top of that, we're catching that smoke at the top of that incline drag, our first point of collection. It transfers into traverses that deliver that asphalt to different silos for different reasons. We collect off of those points. When that drops into a big cylindrical silo, we're displacing air in that silo. There's smoke in that silo already, but when we're adding 400 tons an hour into a silo, we're displacing that cubic volume of air, has to go somewhere, so it goes out of silo vent. We collect from that silo vent as well. So we don't want any smoke escaping off the top of the plant. That's the hottest portion of it, right? And then below the silos are the gates that fill the trucks. Out of each one of those silos, they sit on a scale, the gate opens, they drop asphalt into that truck, one silo at a time. So we vent that area as well with a damper controlled collection point, a horseshoe. when asphalt drops into a truck bed, all those particles separate as they're falling, smoke, and there's smoke in between each little particle. And when they drop into the bed, they compact again. So it's like squeezing a sponge. Instead of water coming out, smoke comes out, and again, you're displacing air in that bed of the truck. Hits the headboard, the tailgate, the sideboards, and goes up. Again, God gave us that. We'll catch that smoke in our horseshoe, and we enclose that silo area, and then blend that smoke, which is pretty much ambient temperature at that point. Maybe elevated. You know, it's an 80-degree day, that smoke might be 82 degrees. And then we blend it with the really hot stuff from the top that could be 300 degrees to drop that temperature down. Because the coalescing feature we talked about earlier, smoke wants to coalesce into a larger droplet at about 120 degrees Fahrenheit. So as we blend that together, we're already getting some coalescing happening just because we're blending hot with cold. And then we start our impact filtration, 7 stages of creating coalescing filters. We're coalescing that smoke all through our system. We're trying to make bigger droplets the whole time so they can be filtered out. So you asked a question about where we're collecting from, and kind of explain that. That's ducting that picks up from all those points.
Right.
Well, to get further involved, each diameter of duct has a cubic feet of volume that goes through the CFM of air. So if we're moving, in one case, 48,000 CFM at a plant, 24,000 CFM is assigned to below the silos. But all those points on top of the plant, the incline drag, the traverses, the silo vents, the batchers, have different sized ducts starting at 8 inches, 1,500 CFM for an 8-inch duct, because velocity through that duct means a lot to us. If you were going to, remember little straws we had that were paper straws when we were kids and at school, you sucked through that, and you sucked it flat because there wasn't enough diameter for you.
That was like the 1930s or 40s, Mike. I wasn't born yet.
Yeah, when you were young, that's why I brought it up.
No, but anyway, yes, I remember those straws. Yes.
So
like
velocity is important.
Yeah.
If you move things through a duct too quickly, it won't coalesce. It just stays in vapor form, vapor phase. We want to move it slowly, so the diameter of that duct allows it to move us at 1,500 feet per minute.
Okay.
And how we blend the top of the silos, which that ducting varies from 8 inches up to 24 inches, to keep that velocity down. Every time we add one more duct to it, we went from 1,500, add one more, 3,000. That duct increases in size to keep that feet per minute correct.
You've got this blue smoke, which is you would consider that a good chunk of your business every year, right? I mean, it seems to be the one that when people think of you, blue smoke, it's like that's what they say when they think of Butler-Justice, blue smoke.
I think so, and we're proud of that. Really proud of our team. We're a small boutique company that services everything to us. And we have long-term employees that every single one of them contribute. They each, it's kind of like Liam Neeson. Everybody has a unique set of skills, and it comes together to make a pretty nice cake. And we all care about our customers. We know that I don't write paychecks. Our customers pay us. They're our boss. And when they're happy, we're happy. And everybody here, everybody is key to our company and its success. We need leadership, we need innovation. We're really, really good at what we do. When you asked about competitors, there are huge companies in our industry that have a blue smoke collector. We're replacing 2 of them right now because they don't work. And I could go in detail about all of them and why they don't, but we think I don't think we stumbled on a solution. We create a really good solution, and we massage that solution all the time to make sure we're doing the right thing.
The next product after Blue Smoke, is the Xbox the next innovation, or is there stuff in between?
You know, the Xbox is being, I think we have 10 out now. We've got 3 just in varying stages in the shop being built. One's complete. It's for hot oil tanks. When a hot oil tank, again, we talk about a tank that's holding hot oil, and when a truck comes and loads that tank, and you know, if this tank is halfway full, everything above the tank to the top is smoke, right? It's like smoke in an attic. It's all smoke. So when they fill that tank with hot oil, it displaces that air, so it pushes that smoke out of the tank. And you know, the smoke is even the smoke out of a hot oil tank is even more egregious than smoke out of a blue smoke collector. It's very strong. So what the air district at one time says, you got to put condensers on those tanks. Well, the condensers really can't take that volume of air and condense the smoke back into a droplet. That's what they're made to do. We built the Xbox as we initially it was an odor control device.
Right.
It's a VOC device now. Volatile organic chemicals, right?
Right. Okay.
And so those are the things that the air districts across the country and in Europe want to control, those volatiles escaping into the air. So again, we use the displacement of that smoke that's in the attic of that tank. As the truck fills it, we very low CFM, because we want to coalesce, you know, again, through the ducting, thin wall ducting that dissipates heat, you know, to get down to a reasonable temperature. And we go through our blue smoke filter, initial filter.
Oh, okay.
Which we know is a HEPA filter. And that filter protects the next 2 stages. And the next 2 stages are coconut carbon, which one is created specifically for sulfur dioxides to absorb the odors and VOC's constituents of sulfur dioxide, which is what we smell. Yeah. We like the smell of asphalt, but our neighbors don't.
I love it.
So we don't want any moisture getting through our filter, any at all, really, into the coconut carbon, because that would shorten its life. So the coconut carbon, we collect, you know, all the VOCs go into one coconut carbon bed, and we absorb those VOCs. 87, I think, is the number. 87 VOCs.
Wow.
And then the final stage is just for sulfur dioxides. So it's made just to collect those odorous constituents of sulfur dioxide in the smoke, and it really works really well.
This
was again driven to invent this. Was one of our local Southern California customers said, I got to do something about this, because their next door neighbor was an adult school, and in the odors in that, you know, in that school, they were getting phone calls daily. The air districts out there daily, and they go, we got to do something about the odors. So we started researching. There's only a couple of ways to do this. You can burn off those VOCs. You can burn them off in a couple of different devices. You're all driven by a refinery where you see that flame that's burning out of the stack.
Oh, yeah.
They're burning off their VOCs there. An asphalt plant can't have a flame, you know.
Right.
Or an oxidizer, which uses the VOCs as a fuel. You know, it's another oxidizer would take that VOC and start a flame with natural gas and heat a catalyst, which is like briquettes. get that briquettes up to 3,800 degrees, and then there's a balance between the natural gas as a fuel or the VOCs as a fuel, and there's a big module that controls those. When one takes over, or it's starving for VOCs, the gas takes over. But that's ridiculous in an asphalt plant.
Yeah.
So, or we can filter through carbon, and the life of the carbon is important. So
that's what you're doing. You're filtering through carbon.
Right, filtering through 2 stages of carbon.
Is this did you engineer this? Or did
Yes. Well, no, I'm not gonna say I did. Todd Fields had, key to this experimentation, the research, all of that. We finally, we tried different.
Todd, what does Todd do for your company?
Todd would be our sales engineer.
Okay.
And key personnel.
Okay.
Very important to our success, innovatively, design-wise, really important fella here.
So, but you had said the other day when we talked that Xbox potential may be greater than that of Blue Smoke. How so?
There are more oil tanks in a plant. Say, for instance, there's one asphalt plant, but they might have 5 oil tanks. So, I guess in a capsule, if you look at the sources of odor, if that's what we're chasing, there's more applications for odor reduction at the asphalt oil tanks, the hot oil tanks, than there is at, the asphalt plant. I think when people build a plant, sometimes they put that American flag on top of the silos, and everybody looks at the flag and they see a flag and smoke escaping right next to it.
Right.
We want to make that go away, because that gets up into the airstream and gets distributed. The solution to pollution is dilution. So when that gets up into the air, it dissipates.
But you say you have around 3,700, or how many potential customers do you have for both products, Blue Smoke and? Easily
3,700, but they don't have to do it. Texas, Florida, Tennessee, the SEC states, they're not forcing them to do anything.
Okay, so there is mandates in place for your Xbox, the use of the Xbox in what states?
Right now, Connecticut, California, Oregon, Washington, Nevada, Arizona, Colorado, Utah is a big point right now. The Wasatch Valley is a big deal. New York has just rewritten all their regulations as far as this. We're doing a project this minute in the city of Chicago, where there's 7 plants, and the city of Chicago dictated that if you're going to sell any asphalt to the city of Chicago, you will have Blue Smoke controls. If you don't, we're not buying any. So this company got $72 million worth of paving and asphalt production because they installed the Blue Smoke collector. So it's mind-bending sometimes to see that there's these solutions, but it takes a government action to force somebody to do the right thing.
Right.
You can spend $10 million on an asphalt plant and whatever on a $500,000 on a Blue Smoke collector and do the right thing for the world, but like it's the casket thing, right?
Yeah.
I would if I don't have
right,
to.
I hear it. So tell me everything that you sell today or engineer. What do you guys do today? Who is Butler-Justice in a nutshell today?
So it's difficult. So we almost have a division of environmental products, right? Which would be our dust collection systems, ducting systems, which is all engineered, designed for, doesn't matter if it's a foundry, a waste management facility, an auto shredding facility, industrial production of a good for our dust collectors that we apply to those industries. And then for the asphalt industry, obviously the Blue Smoke collector is huge, which we put it, we were told not to, but we put them at auto shredding facilities, and they've been very, very successful in reducing those problems. and then the Xbox. So that's really dust collection, blue smoke control, and Xbox are the three products that are going to be environmental products that we're responsible for design, installation, maintenance, etc. And then other than that, obviously the crusher screens, Terex Cedar Rapids, Simplicity. You know, we probably sold well over 3,000 conveyor belt scales in the world.
Can you name those again? Who you're a dealer for? I just want to make sure I get that.
Terex Cedar Rapids, Terex Kanika, Terex Simplicity. Those are all one group of families under the Terex umbrella. Rock Shield, which makes abrasion resistant vibrating screens, you know, rubber, polyurethane screens for aggregate plants. Spalding Equipment Parts, which are crusher parts. Manganese, cone liners, jaw liners, crushers, crusher equipment, beltway belt scales, the Donaldson dust collectors, again, for the aggregate plants. Can't even keep going. You know, we require that we have cement. We require that we refine oil. We require that we need diesel and gas. We require, no matter what anybody says, we're not there yet to run on electric, right?
Right.
So as we just look at the world evolving and what dictated, we want to be there as a small engineering company that provides a responsible product and does a really good job. We want to be there. So I don't know what's next other than continuing to develop the products we have and make them better and massage them and just make them more responsible.
Okay. Now, do you think if Mike was looking down on you and if Mike Justice was looking down on you and he has seen what has happened since, was it 2008?
2006, yeah.
2006. From 2006 to now, do you think he would would he say, well done? What do you think he would think?
You say, Butler, what are you thinking? We should be doing this now. We should be bigger. We should have a big building. We should have 50 employees. Let's move it along, son. You know, his brain was so much better than mine.
Oh,
he would expand it. He would say, good job, but hey, we can always do better, right?
Okay, that's fair. Why are you a member of California Asphalt Pavement Association?
Oh, California Asphalt Pavement Association is so key to the success of our customers. You know, with public sentiment now about the construction industry, the encroachment of people, you know, towards asphalt plants, you know, urban or not, we need to keep understanding that our customers are good people and they produce a product that we have to have. Whether people, you know, at the moment go, hey, my backyard smells like asphalt, you know, the agency, Russell and his group work, and you guys, you know, I mean, work so hard to keep the positive slant on what we do. This is a very, very important industry, and public sentiment, Facebook, Instagram, all these social media devices that the world has at their fingertips can only state a negative. They never see where you came from, what you developed, what you're solving, until an agency like CalAPA points it out. You know, we have to let the world know, and that's our only voice, right? CalAPA is so important to furthering our industry and our customers, who are all good people and employ so many good people. There's not a bad guy in our industry.